Hi, thank you so much. ありがとうございます。Konnichiwa, minasan. So, okay, so yeah, my name is Andreu Botella. My pronouns are they, them. I work on browsers and standards at Igalia. If you just just now, my colleague Joey was talking about modules in Node in the other room. Yeah, so Igalia works on a bunch of stuff related to this, also not related to also stuff unrelated to browsers and standards. I don't know, the recent Valve releases, we've done some stuff related to that in the Linux kernel and stuff related to that. Anyway, but that is kind of outside of my wheelhouse. Yeah, so I'm working on WinterTC, and in fact I am co-chair of WinterTC alongside Luca, and we'll see a bit of what that means later. So server-side runtimes, right? Let's have a bit of a show of hands. How many of you use node.js? Okay, almost everyone. What about Dino? Just a number. Fun? Still a lot more than I expected, but for workers. A few. Okay, so all of these are server-side JavaScript runtimes. You might Vercel is not on that list because they. I'm pretty sure that on their server, on their cloud platform, they just run Node.js. But for Cloudflare, that they are not running Node.js. They have their own product. So I want to discuss a bit the difference between runtimes and engines, because I get I see this confusion a bit. So you have the JavaScript specification, ECMA 262, and this defines the JavaScript language, but it defines really no input-output, and there's an asterisk there because technically now it does define one piece of input-output, but unless you're dealing with shared memory, you shouldn't have to care at all about it. And so I'm going to treat it as if it did not define any either. And yeah, JavaScript was always designed to be a scripted language embedded in a larger system. And that larger system would provide a set of APIs included in JavaScript, but not part of the language, to interact with this larger system. What's what we call a runtime environment. This environment could be one that gives you server-side capabilities, or it could be a browser. If you think about it, the browser just produce stuff on screen is IO, even if you have to do it through the DOM and CSS and so on. And browsers can also do network requests, so it still is a runtime environment. It's just one with particular constraints. So with this in mind, the JavaScript engine is the piece of software that implements the JavaScript spec, typically a library, and which is used by the JavaScript runtime, which adds APIs to make JavaScript useful. And server-side runtime, so well, basically servers. Server-side runtimes. So in terms of interoperability, being locked to a single platform is not great. You shouldn't need to completely rewrite your code all over again when switching from runtimes to services. You might need to you might be looking at the prices for different services, and now it's not just the difference in cost; it's the overhead of switching that you need to consider. And ideally, it would be best if the APIs and the functionality would be shared across server-side runtimes. The big selling point is that they all use JavaScript, right? That is already one thing that you share. Why not share more? And yeah, you should share as much APIs and functionalities as much as it makes sense. But maybe sharing too much is not feasible. If you want to implement all of the Node APIs and all of the browser APIs and all of the Dino APIs everywhere. That's not feasible. So we need to choose what we expose. How about exposing Node APIs? And this has been the case to some extent in the server-side runtime system. Is it a good idea, though? I will argue that it isn't really. Many of the Node.js legacy APIs are real, and some of them, especially, they're basically using callback style of asynchronicity, which is not really suitable for modern JS code that uses async await. There is documentation, and it's fairly good, but there is no comprehensive specification. A specification in like the web standards define everything in detail, and that is not to say that the standards are not wrong ever or that there is no contradiction, but they are meant to describe everything in detail so that they're like the goal is to not leave things undefined. That is always a goal. Obviously, they're written by humans, and it would be worse if they were written by LLMs. But yeah, there is no good test suite for Node.js. There is one, don't get me wrong, but it's not it's not the kind of test suite that I'm used to coming from the standards side. It's like one feature was added, and sure, let's write tests, but it's not a comprehensive test suite. It's not meant for other runtimes to implement. And these APIs were only ever meant to be supported by Node.js, not by other runtimes. And sometimes trying to make it work, like there are some minor differences in timing of things because of the way the things are implemented internally. And like this also affects the test suite. Sometimes the test will not pass, because the exact mechanics of Node.js are part of what's being tested. And some Node.js maintainers do agree that some APIs are awful. In particular, like Joy and Marco said that HTTP APIs in particular were pretty bad. And if you ask me, I think that rather than betting on Node APIs, the server-side runtime ecosystem should instead bet on the web, on being interoperable with browser APIs. This allows you to reuse code with the front end. There are already tons of, many polyfills such as isomorphic fetch that you wouldn't need to use. Sure, now that fetch is implemented in Node, there are still uses of isomorphic fetch, but because it is a dependency of many other packages in VM, but the idea is that eventually, hopefully in the long run, it would not be needed anymore. There's the learn once, write anywhere factor. What I was saying before about having the benefits of a single language, having the benefits of common APIs is also part of what this brings. And the web has a huge comprehensive documentation that is really good at MDN. The folks out of WebDocs do an amazing job maintaining MDN, and And I want to quote something from Luca Casanato, which is the alongside me, the current co-chair of WinterTC. This was when WinterCG was initially formed. When using a web interoperable runtime, you aren't learning new platform-specific APIs or functionalities, but rather you are investing in your knowledge of the largest and most important platform in the world, the web. I think this is basically what it means. The web is the largest and most important platform in the world, and we should use it. And I should say that rather than a web interoperable runtime here, this blog post said Dino, but because Dino was one of the founding members of WinterCG, and it applies to web interoperable runtimes in general. And I think that's what we're trying to build, to make runtimes web interoperable in that sense. But there are some challenges with web interoperability. it's not just let's implement all server side, let's implement all web APIs in the server side, and well, you have the existing problem that different server side runtimes support a different set. You don't have anything like baseline that you have in the client side now, thanks to the work of Google DevRel and WebDX and like baseline has been something that has helped client-side development a lot, and we don't have anything like that for web APIs and server-side runtimes. There's like in the when talking about applying the specifications for server-side runtimes, the specs are written for browsers. Server-side runtimes don't have origins, and like if you pass a relative URL to fetch, it gets resolved according to the current URL of the current page. There's no such thing as server-side runtimes. So, like in this case, I think everyone throws because that's the only behavior that makes sense. But there are cases where you can have more complicated, like or where the behavior might not be as clear. And sometimes server-side runtimes might want to actually extend web APIs in ways that aren't such a priority to browsers. Whether that is because, like something like. I actually removed this from the spec, but I might just mention this briefly. Not remove it from the spec, remove it from the slides. The Web Crypto API currently doesn't support streaming, and it would. There are some challenges in making this work, but having some Web Crypto API that could encrypt or decrypt or hash based on streams, that is something that. It would be really relevant for server-side runtimes, especially when for encrypting and decrypting and stuff. And it's not such a priority for browsers because browsers typically don't need to deal with huge data when encrypting and decrypting stuff. And but it's something that would not be out of place in browsers. It's just not such a high priority. And all of this in general. Needs a standards body to coordinate things between the server-side runtimes and the web specifications. So that is what we're trying to do in the Web Interoperable Runtimes Technical Committee, aka WinterTC. And like, if anyone has ever wondered about the name, it's Web Interoperable and Technical Committee or Community Group for WinterTC. The goal is to make non-browser JavaScript projects more interoperable among them and with the web. As I said earlier, you want to write from one runtime and run anywhere, enable shared code between the browser and the server, and basically expand the common baseline of functionality available in all runtimes. And as I mentioned, this work started as WinterCG, which was a W3C community group. This allowed us to have some open collaboration without needing to have membership requirements in the W3C. The problem is that we couldn't publish technical reports or standards. This is due to basically patent bullshit. Like, patents are bullshit. but yeah, it's intellectual property requirements, whatever. And yet, the thing is, in order to publish standards, we needed to become an ECMA technical committee, and we did become technical committee number 55, officially designated as TC55. As you could the work that the technical committee that standardizes JavaScript is TC39, but the common name is WinterTC. Because why not? And one of the main things that we are aiming to publish is we are working on publishing is the minimum common. Actually, this should be minimum common web API, which defines a common baseline functionality of things that should be implemented in all server-side runtimes. And we are also working on a WinterTC test suite that would allow us to test the minimum common API. This is based on WPT, if you're familiar with it from Interop or something like that. And we are also working on this has a bit lower priority for us, but we are working on enabling a unified API for sockets, especially low levels such as TCP and TLS, and also to have a unified API for mVars, arguments, and other things in a CLI application. And for the minimum common API, the goal is to include like many or really almost all of the compute-only non-IO APIs that you have in the web. URL and URL pattern are just compute-only. They're meant to be used for URLs, and but it's not like you don't need to like you can use these APIs without actually doing network requests. But you also have in the minimum common API general purpose async IO APIs like fetch and set timeout. And this is actually, not many people know that set timeout is not defined in the JavaScript spec. It is defined in the HTML spec, but like Node has implemented it since forever. And so Node has been to some extent web interoperable since forever actually. And yeah, as a web dev, if you code against these APIs, the goal is that your software would be interoperable in the web and across runtimes. And this is also like we're looking into doing this test suite so that this works like that, and using a subset of WT to ensure that. And we are currently starting to look into having TypeScript declarations for the minimum common web API. This is something that we have only started looking into because we were first looking at what the APIs were, and now then we worked on actually preparing an edition of the minimum common API to be published in December, which this past few weeks I've been having to deal with a lot of editorial changes and stuff about generating an ECMA PDF from a spec generator that actually doesn't like ECMA's format very much, but anyway. And well, yeah, in the future, the plan is to have conformance levels that span beyond the minimum common API. So things that sit on top of it. Maybe something like graphics to have headless web GPU, off-screen canvas, image direct, but still in a server-side environment. Like you could use, I think Dino uses some of these APIs. Not off-screen canvas. Does it use web GPU? I forget. I think Andromeda does have some of these, like CLI and file system level that would include these APIs. So Cloudflare workers, for example, would not have a CLI and file system level because they don't have a file system, they don't have a CLI. But other server-side runtimes could happen. And then server level, including maybe advanced working APIs and HTTP server APIs. So let's talk a bit about the fetch spec, because you might think that there's not much here other than what I mentioned earlier about passing a relative URL. But I want to take a look at to use this as an example of the kinds of things that we have to deal with. So this is fairly simple, right? You would think so. But the spec, as I said, is written for browsers, and in server-side runtime, you don't have a current page, therefore no current URL, as I mentioned earlier, no origin, no cookie jar, no referrer, and all those things are assumed in the spec. Like at some point, it's like, so you check the current origin matches the origin of the URL that you're fetching, and it's like, there is no current origin. So what do you do with that? And server-side runtimes also don't need cross-site request protection. Like you don't have like a cookie jar, so you don't have any authentication information that is included by default. So if you do a network request, there's no possible way to communicate authentication information that you're not explicitly wanting to communicate. And so these are some of the ways in which things server-side runtime need to work differently. And I say this, but like the goal is for developers to not have to worry about any of this. Like ideally, things like cores are a necessary evil in the client side, and you like if you have to worry about it in the server side, it's probably a bug, right? Well, other than for like having the right response handlers. So ideally, this should not affect developers in terms of interoperability, but it's something that needs to be handled. And there are some additional features that are only really needed for servers, like configuring the allowed protocols, which level of HTTP. There's, well, hold on. Okay, I'm not seeing this. Ah, good. Let me find this. Wait, where did I put this? Where's my mouse? Can't find it. I actually have 3 screens where one of those is fake, and I think now should. Oh. Where's my mouse? Let me try to drag this to the right workspace if I can. Well, I'll do it like this, just looking at the screen. Okay. So yeah, you might want to programmatically configure TLS like things, certificates, HTTP proxies, connection pooling. Those are various things that you might want to handle, especially as a server, and that are currently not supported in the Fetch API. And well, yeah, the goal is for all of this is to update the spec, like to actually modify the Fetch specification. And to be able to test these behaviors so that all server-side runtimes know how to behave and they behave the same in these various things. And as I mentioned, there's the WinTC test suite that we're working on, because a standard is worth very little without a test suite. And the web platform has a huge and very useful test suite, which is WPT, Web Platform Test. This is actually, I'm gonna go script for a bit, because why not? When I work on browsers, like the WPT is a test suite that is shared across all browsers, and it's everything that, like, I make a change in Chromium, and I'm encouraged to write a test, like to add tests into WPT, and I just make them in the change in Chromium, and they get automatically pushed to the upstream repository, and then eventually other browsers get them, and that way we have like sometimes you can end up with tests that might not actually follow the specifications because they might not be like written explicitly to test the specification, but having this shared test suite with and like having a common understanding that we want to like that we can fix it, fix tests that are wrong and so on. That is huge, and that is a lot of what has that's what has enabled interop and a lot of the interoperability advancements in the client side for the last few years. And yeah, even if it's not a formal, let's actually test everything in the spec test suite is still like it still ends up being kind of like that because you are testing things as you're implementing it, and it's not just let's test whatever. It's testing each little thing as you're implementing it. At least this was my experience while working on something that is very unrelated to WinterTC. This is my experience working on layout things in CSS. You know, I have too many roles, too many jobs. Okay, but yeah, that was a I'll stop going off track. Yeah. So yeah, we are identifying a subset of WPT that is the minimum common API, and like sometimes some of the existing WPT tests use APIs that are not in the minimum common API because they were written to test things, assuming that other APIs and browsers were a thing. This is especially the case in structured flow, which where you you test what happens if you serialize dump rec, what happens if you serialize an HTML element, what, and so on. And you need to take those tests and make sure that those APIs actually exist in the environment in which you're running the tests. So sometimes we might need to modify tests upstream so that they don't assume things that go beyond a minimum common API environment. But this is again with as with Fetch, the goal is to do that upstream, and maybe we could have a WinterTC equivalent of test262.yi or the interrupt tracker, which shows you like which server-side runtimes have which percentage of completeness in the test suite. And yeah, so is this only for server-side runtime implementers? Does this involve you in any way other than for the things that I've mentioned earlier about type definitions? Yeah, we want to hear your needs. Like for me in particular, I working in a bunch of places, but I'm not actively doing web development anymore. And sometimes that experience really is needed. What are your pain points? Just if you think we should be doing more in some aspect or other, you could come and tell us. And like this is our links. We have meetings every 2 weeks. So Friday at 4 p.m. CEST, which is like it's midnight here in Japan. I'm sorry. That's how time zones work, and we currently don't have enough people to have a rotating schedule. I'm sorry. Like most of people participating are in Europe and in the US, and if enough people want to show up from Japan, for example, we could try we could see if we can change it to a more favorable schedule. But at this point, it's like it's not easy to find a time that works well for everyone. And you must be an ECMA member or a WinterTC invited expert to attend. But we have tried to make the invited expert process to be as easy as possible. As in one of the previous slides about WinterCG, one of the reasons we went for a CG is to make it as open. Here, it can't be as open due to the ECMA process and intellectual property requirements, blah blah blah. But it is filling out a form and waiting for me to notice which. Ping me if it's been over a week or something, and I like the goal is to make this as easy as possible, considering that there are things that we like that like kind of hurdles like need to be overcome like that. But it's a lot easier than in other groups, I believe, and it's. Basically, it starts by filling out a form in the actually. If I can find this, can I actually show this to you? No, because I'm on a private tab. Well, okay, I don't think I can show you this very well. But if you go to WinterTC 55/admin, go to issues. One of the issue templates is new invited expert, and you just fill that, and we'll handle it from there. Well, you will also have to fill out an ECMA form, but it's 2 forms. Okay, it's as easy as we could make it, and yeah, that's it.
We can take questions.
Sure. Like, does anyone have any question?
質問がありますか? I think we have time for 2 questions for the speaker. So
you mentioned several plans for adding test feed or adding so I'm particularly interested in test feed. So my question is basically, do you have any particular or concrete timeline for that, or are you basically working on the discussion right now?
Yeah, so we have currently identified a subset of WPT that would be the the minimum common API test suite. The thing is, we are finding how to test, how to make sure that those tests are appropriate, that maybe they don't depend on other APIs without having to go through each of them individually. And we might still need to go through each of them, but it's currently all server-side runtimes implement the minimum common API plus some other APIs. And if we run them in Dino, for example, could it be that there is some test that relies on some API that Dino implements, but it's all part of the minimum common API? And that is the current challenge, but we have identified a set of tests, and unless we find that is, I think the structure clone tests do need some changing upstream, and for the rest we need to make sure that those are those can be used for the minimum common API test suite.
Thank you.
Sorry, I think that's all we have time for. Thank you again, Andreu, for